Okay, so anytime I'm talking about related rates, we got to think about that word rate. What does rate mean? When have we seen rate in this class?
Rate of change.
Rate of change means slope, and then give me a calculus word for rate. Derivative. So this is going to have to do with derivatives. Okay. The related part is because there's going to be relationships between the different variables, and you'll kind of see that as we do an example. So when you're solving related rates, you're always going to want to read the problem. You're going to want to identify what you know, what you don't know. There's always going to be an equation. You're going to differentiate implicitly. This is why we just studied implicit differentiation, because you need it for these. Always with respect to time. So what this means is you're going to see a lot of d somethings over dt. That's going to be your denominator. Okay, so before we had dy over dx. Since these are real life problems, we're going to use t. And then we're going to evaluate the derivative, and that just means you're going to answer the question. Okay, I have a little acronym that's going to help you remember what to write down when you read the problem. These problems are not one-step deals, okay? And there's a lot of information, and to know what to do with it can be confusing. So what I like to do first is find, and I call this Swiggy, by the way. The first thing you're going to do is find, like, what are you trying to find? Okay? Basically, what is your answer going to be? You need to identify that first, even though that's going to be the last thing you actually do. Okay, W is going to stand for when. Okay, I'm going to put a little ... because in every problem, they're going to say when the radius is 3, or when the height is 9, or when the area is whatever. All right, and so this is going to be something that's known. Okay, the when is going to be known. Okay, G stands for given. You're going to be given other information in the problem besides the when part, and so this is the other part of your known. So W and G together are your knowns. These problems aren't going to give you extra information. So if they give you something, you need to be writing it down in the beginning because it's going to be important. E is going to stand for equation. The equation that relates your variables together. On a lot of these, the equation's given. If the equation's not given, then that means that I expect you to know it, like area of a circle or something like that. Okay, so every time we work one of these problems, we're going to do Twiggy, we're going to write down the information, and then we're going to go in and actually do the calculus, or we take the derivative. Okay, so on number 1, I'm going to change, that's fine. Okay, on number 1, let's go ahead and write Twiggy over here on the left. And I'm going to read the problem, and I want you to think, what are they asking you to find? Okay? So it says, air is being pumped into a spherical balloon at a rate of 4 pi cubic feet per minute. Determine how the radius is changing when the radius is 18 inches. And then they give you the volume of the sphere. What are they wanting you to find?
Change of radius.
Yeah, the rate of change of radius. Now remember what I said about rate of change? That's derivative. So what they're wanting you to find is dr. That's how the radius is changing, and always this is going to be with respect to t, with respect to time. So let me repeat that. This says determine how the radius is changing. Anytime you see rate, change, or rate of change, they're talking about the derivative. In this case, we're talking about the derivative of the radius with respect to time. That's what we're trying to find. And our final answer is going to be dr over dt equals something. And that's going to tell us how the radius is increasing or decreasing. All right, when. Okay, let me read this problem again, and you see when you hear the word when. Air is being pumped into a spherical balloon at a rate of 4 pi cubic feet per minute. Determine how the radius is changing when the radius is 18 inches. So I kind of emphasized it here. What's after the word when?
R equals 18.
R equals 18, and we are going to be good little students and use units. Okay. All right. Now I'm going to read it again, and I want you to think about any information that's given that I haven't written down yet. Air is being pumped into a spherical balloon at a rate of 4 pi cubic feet per minute. So it's a rate, which means it's a derivative. The derivative of what? Volume. How do you know that? You're filling up a 3D shape. What about the units might help you know that this is volume?
It's cubic.
Cubic. Cubic is going to be volume, all right? Squared is going to be area, and so on. So dV over dt, that equals to 4 pi cubic feet per minute. And I already have an issue. What's my problem? What's not really measuring up? What's not lining up here? Feet and inches. I need to change one. Which one is easier? You think it's easier to change the radius or the dV over dt? Change the radius, because if I do this here, my scale factor has to be cubed. I don't want to do that. All right, so how many feet is 18 inches? 1.5. 1.5 feet. And what I'm actually going to do is cross that out, because I don't want to accidentally use 18 later when I need to be using 1.5. All right. The equation, like I said, sometimes you have to figure it out, but a lot of times it's just right there. You will, just by working out these problems, memorize this equation. We're going to do a lot with spheres, circles, and cones. And there are other shapes, but we do a lot with spheres, okay? So, that's how you fill out the information. Now for me, you already got points on this problem. Not all of them, but you already got at least some of the points. And all you did was read the problem and write down some information. Okay, now to get the rest of the points, what we need to do is we need to work our way back up. This is also why I like Fwiggy. We go through and we find the information in order of, maybe not importance, but in a particular order, and then now I'm going to work my way back up. So I'm going to start with the equation. So let's rewrite the equation here. V equals 4/3 pi r cubed. And what am I going to do to this equation? I'm going to differentiate implicitly. That's what the steps up at the top told us to do. Okay, so always you're going to differentiate with respect to t. Okay, so I'm going to do that over here as well. D over dt. All right, now this on the left here, we're just going to rewrite it as dv over dt. And this should look familiar because we wrote it over here as one of our givens. So later on, we're going to plug in 4 pi in for that. Okay, but before we do that, we need to finish taking the derivative. Now this is 4/3 a constant times pi a constant times r cubed. All right, now since I'm deriving with respect to time, this is not a t cubed. So I can't just take the simple derivative. So think back to yesterday when we were doing implicit differentiation. Are we going to treat r like an x or a y? A y, right? It's not the same variable. So let's do the power rule, and at the end we'll write our statement that we need to. So 3 times 4/3, that's 4, then pi, and then r squared. Okay, by the way, this is the surface area of a sphere formula. When you take the derivative of volume of a sphere, you get surface area of the sphere. There's a lot of relationships like that. What do I need to multiply by? dr over dt. What this is like is when before we wrote dy over dx every time we took the derivative of a y. Here we're doing the same thing but with r and t. All right, now remember which one you're trying to find, because if it's in multiple places, you're going to have to do some factoring. I will tell you in related rates, that's rare, okay? You are, though, going to need to plug in, though, what you do know. So we do know that dv over dt is 4 pi. We do know that r is 1.5. This, again, is why you want to write everything nice and neat over here, because it's going to make the rest of the problem easy. So notice, I started with the equation. Then I went and plugged in my, after I took the derivative, I plugged in. And eventually what we're going to be able to do is find that first thing. Okay, so dr over dt. So what is dr over dt? All right, so I'm actually not going to simplify. It's going to be 4 pi, well, we are, but right now, not going to worry about it. 4 pi over 4 pi 1.5 squared. Do y'all see how I got that? I just divided by what was in front of dr over dt, and I just put dr over dt on the left. Okay, the last thing you need to do is make sure you have the right units. This right here will tell you your units. What were my units for radius? Feet. It was originally inches, but we changed it to feet. And so feet per, what are my units of time? Minutes. This is a totally acceptable answer. You don't have to solve it out any more than this. On the calculus AP test. In my class, though, I do want you to solve it out, but you have a calculator, so this should not be difficult. You are going to have to be careful about, parentheses. You need to make sure that you're dividing by this whole thing. So go ahead and plug that into your calculator and see if you can get an answer. So, anybody get it? 4/9. Anybody get 0.444444? Okay, anytime you get a number like that, it's that number over 9. So 0.77777 is 7/9. That's just side knowledge. You don't really need that. So 4/9 feet per minute. That's your answer. This is a positive number. Does it make sense that my radius is changing at a positive rate?
Yeah.
Yeah, because it's increasing. All right? This is the rate at which we're increasing. No, if you're accurate to 3 decimal places and you write 0.444, that's acceptable. Okay, so that's a related rates problem. So these are not quick and easy either, but if you follow this Twiggy, you're going to be able to work through the problem. You just do one thing at a time. I'm going to tell you that I can't look at this, I can't read this problem and know what the answer is. And I know related rates really well. So you can't either. You have to do work on these. It's just too many things going on. If you can do that in your head, then you need to be out of calculus and onto college. Something else. All right, so here's 2. Okay, what I want you to do, I'm going to read the problem, and I want you to fill in Twiggy as best as you can. All right? Remember, F is for what you're finding, W is what you write after the when statement, G is any other givens, and E is your equation. So this says the circumference of a circle is increasing at a rate of 2 pi over 5 inches per minute. When the circumference is 10 pi inches, how fast is the area of the circle increasing in square inches per minute? So read back through that if you need to. Fill out your Twiggy and check with a neighbor. And you may decide that there's more than one thing that goes in a blank, and that's fine. y'all look like you either got it or you're stuck. One of the two. So what are we trying to find here? The rate of change of area. It says, how fast is the area increasing? So what does that tell us about dA over dt? If we're increasing, our answer has to be positive. So that's something to look out for. Okay? We're going to do a decreasing one next. So what was in the when? Oh, yeah, that's what we're looking for. What's after when? C equals 10 pi inches. Is there anything else I can get out of, if I know circumference 10 pi, can I find something else?
Radius.
The radius. You guys know enough about geometry to figure out that the radius is 5 inches. This is going to help you out if you know that. If circumference is 10 pi, radius has to be 5. All right. What else was given? The circumference is increasing. So how would I write rate of change of circumference? dc over dt, and that is 2 pi over 5 inches per minute. And we want to make sure we use our units so that everything lines up and we got it. All right, and how many of you wrote this as your equation? Okay, how many of you wrote this? Anybody? How many of you wrote both? Okay, it's probably going to be a good idea to write both because this problem has to do with area and circumference. Okay, so here's what we're going to do here. Because I have two equations, you've got to start with one of them. This is what I would suggest. Look at what you're trying to find. I know for sure I'm going to have to differentiate this area formula in order to find my answer. So let's start there. And if we get stuck, we'll go and we'll differentiate the other one. Okay? So I'm going to rewrite a equals pi r squared. And then I'm going to go and I'm going to differentiate. Remember, you start with your formulas and then you work your way back up. So d over dt. And then over here, same thing, d over dt. So dA over t, or dt. And what would the derivative of the right side be? What? 2 pi r. Well, that's interesting. Derivative of area is circumference, not a coincidence. All right. And then what do we got to put at the end? dr over dt. Okay, so in the last problem, we plugged in something here, we plugged in something here, we were looking for dr over dt. In this case, I'm trying to find out what is dA over dt. So all I need is to plug in these two, and I got my answer. Except that I know my radius, but do I have anywhere on my paper what dr over dt is? No. So this means we're going to leave some space here. We're going to come back to this, but this means I've got to use my other equation. This is why it's a good idea to write down any equation you think you might be using. All right? So let's use this one, and I'm going to go ahead and just work from here. d over dt, d over dt. That's going to give me dc over dt. And then what would the derivative of 2 pi r be? 2 pi times dr over dt. The reason this is going to help me is because, okay, can I find dr over dt? Well, I can as long as I can plug something in for dc over dt. And this is, again, why you want to write all your information over here. So look, do we know what dc over dt is?
2 pi over 5.
It's 2 pi over 5. So 2 pi over 5 equals 2 pi times dr over dt. What does this make dr over dt? Yeah, I mean, here's the deal. If you're feeling lazy, it's 2 pi over 5 divided by 2 pi. But look at it. What's dr over dt? It has to be 1/5, right? 2 pi divided by 5 equals 2 pi. This has to be 1 divided by 5. Okay? Let me move that up just a little bit so everybody can see it. All right? But if you wrote 2 pi over 5 over 2 pi, you could either simplify this in your calculator or not at all. But since I'm not done here, since I'm actually going to have to plug this into something else, it might be a good idea to simplify as I go. I mean, you have a calculator anyway, so it shouldn't be that hard. All right, let's go back up here to my problem. So remember, we're trying to find dA over dt. We know R is 5. We now know that dr over dt is 1/5. Yep. So this again, you didn't have to simplify it, okay, on the AP test, but I want you to simplify so that you have an answer that actually is something we can think about. Okay? Hopefully you can see that step right there. But if not, you had a calculator, so your answer is 2 pi. Units here. Area is inches squared. Time is minutes. So there's my final simplified answer. What this means is the area is changing 2 pi. It's increasing 2 pi inches squared per minute. And that was what our question was asking us. And the answer is positive, which is good. Yes?
About the false answer, where'd you get the 5?
The 5 I plugged in for R, since R is 5. Good question.
What does the 1/5 have to do with it?
So when I differentiated my area formula, I had to write, this dr over dt came up. And I wasn't given dr over dt. Like in the last problem, that was something that was given to you. In this problem, instead, they didn't do dr over dt, they did dc over dt. So what we kind of had to do is go off to the side, use circumference to then find dr over dt.
You're between dr and dc, if I change the radius, you change the circumference.
Correct. dr is changed radius, dc is changed in circumference, and those are not the exact same.
dA is area.
dA is area.
But we have a little more room.
Yeah, I mean, you can see that I changed this to where I have a whole lot of room here. On a quiz, I will definitely give you guys lots of room because that'll make it easier for me to grade. All right, let's start the last prop. We're going to skip that, number 3, by the way. Go ahead and go to number 4. And at the top of this, I want you to write this phrase, cones are special. Cones are special for a few reasons. All right, one is you don't really do a whole lot with cones. We do conic sections in algebra, and you do a little bit of cone stuff in geometry, but you haven't dealt with cones like how you have circles and even spheres. You probably dealt with spheres. Cones are kind of an interesting shape. Most of the time, cones are going to be inverted like this. Think of like those old school snow cone cups. That's what this is. And then something, water is dripping out, okay? So here's what, the other thing is, there's 2 dimensions to a cone, whereas a sphere and a circle, those just have radius. A cone has a radius and a height that are both changing. Yeah.
Instead of the area of the base, why don't they just put pi r squared?
Yeah, okay, so the question is, and why did they put big B here instead of actually writing what it is? And that's just a convention. This big B is the area of the base, which is pi r squared. And you need to know that. How does volume of a cone relate to volume of a cylinder? It's a third of it. It's a third of it. A cone is a third of a cylinder. So a good thing to know is if you ever buy a drink that's in a cylinder glass, which hopefully you guys are not yet, all right? But sometimes places serve good drinks, that are not alcoholic in a cone glass. But if you ever buy one in a cone glass, it's a third of the volume of a glass of the same height and radius. Not half, a third. You get a third of the amount of the liquid. This is why they serve martinis and stuff in cones, I mean, it doesn't just look fancy. I mean, they're giving you a third of the liquid. So, you know, for later on in your life, hopefully. All right. So here's what I would like for you to do. I would like for you to read this problem on your own, and I want you to go through and do Fuigi and label the diagram. And go ahead and do that part on your own. And then we're going to go over it, and that we'll call it quits for today. Okay, so tell me, what are you trying to find here?
DH or DT?
dH over dt. We know that because it says the height of the water is changing. Is dH over dt going to be positive or negative? It's going to be negative because if water's coming out of this cone, the height's going to go down, right? It's going to decrease. All right, what about the wind? Wind what? When the height equals 3.
Sorry.
All right. Now the other givens, okay, let's look at this one. What was 2 cubic feet per minute? Yeah, how did you know, and I'm going to have to just go creep in on the E's part, but how did you know it was volume?
Decreasing volume, increasing this attraction.
Yeah, volume is also going to decrease. So we're going to have -2 cubic feet per minute. All right?
Why is it not
Why is it not what?
rate?
It is a rate. Anytime you have d something over dt, that's a rate. Like before, r was not standing for rate. R was always standing for radius. If that clears it up. That's a really common thing. It's kind of like, I hate that radius and rate will start with R.
Why there's R.
Yeah. It's V because this has to be volume in the unit to give that away if you weren't sure. All right. Also, it says the cone has an altitude that's the same as height, okay, of 10 feet and a base of diameter of 6 feet. Can we write that any better?
R is 3.
R is 3 feet. Now, here's something that's interesting, and we're going to talk more about this tomorrow, which is I just said that H is 3 feet. You have 2 different things going on here. You have the big cone, like your container, and then you have the current condition. That's why I want you to distinguish the when. The when is going to be right then, okay? So later on, when we plug all that stuff in, we're going to plug in 3 in for H. This business right here is going to give us a relationship that we're going to need when we get stuck, okay? But again, we're going to do that tomorrow. All right, E, I kind of, I didn't give enough space for E, but we've already said it, 1/3 pi r squared h. Is there any other equation? There's not. It's okay. It wasn't a trick question. All right, so the altitude of this cone was 10 feet, and the radius was 3, but later on, okay, the height of the water in the cone is going to be 3. What can you tell me? No, I don't want to know the number, but I want you to tell me what's the relationship between these 2 cones? They're the same shape, but they're different size. What do we call that? Similar. We have some similar cones, some similar triangles, so we're going to use proportions. Okay, and with that, we're going to pick up tomorrow.